Okay, so we talk about 3 quantum numbers, but I told you there are 4 quantum numbers. The fourth quantum number is spin quantum number. Spin quantum number is it spin around its own axis. Spin quantum number is easy. It gives you plus half or negative half for each spin. And then with that, we are going to the Pauli's exclusion principle, which is very important when you write electron configuration. Pauli's exclusion principle says no two electrons in a same atom can have the same set of 4 quantum numbers. That means even if you take electron in a same atom, these electrons in each individual electron has its own set of quantum numbers. With knowing that, let's see how we can write the electron configuration. Electron configuration, always you write, like you need to know how many electrons in an atom. Example, hydrogen, you have only 1 electron in hydrogen. Let me take the black color. Hydrogen has 1 electron. 1 electron, you write, okay, it's 1 is principal shell, orbital, S shell, 1s1. 1 is orbital, S is the type of orbital. This is principal quantum number, type of orbital, number of electrons. Let's go to helium. 2 electrons, you write 1s2. Always S shell can hold up to 2 electrons. S shell, 2 electrons. P shell, you know P, L equals 1, 3 P's plus, so that means plus 1, 0, negative 1, 3 P's. Each orbital hold up to 2 electrons. Altogether, P shell hold up to 6 electrons. D shell, there are 5 D's. If you think why it's 5 D's, L equals 2. When you write ML, negative 2, negative 1, 0, 1, 2. 5 D's, altogether 10 electrons. Okay. So then helium is 1s2. After helium, you go to lithium. Lithium, 3 electrons, 1s2, 2s1. Okay, because it's second shell. You go to beryllium, 4 electrons, 1s2, 2s2. Boron, 5 electrons, 1s2, 2s2, 2p1. Like that, you can go up to 2p6. Hope this short video will help you to understand how to write electron configurations. And then always keep in mind when you this is called electron configuration, and you can always also write orbital diagram. Orbital diagram means each orbital you did represent in a small square. Let me show you for the boron. So 1 is you have 1 orbital, so you draw a little square. So this is a square you draw. You have 2 electrons up, down. 2, you have 2 electrons up, down. 2p, 3p orbitals, 1, 2, 3, 1 electron up. Carbon, 6 electrons, 1s2, 2s2, sorry, 2s2, 2p2. 1 box for each orbital. Down. And then p, you write 1. Is it going? No. When this is the next rule, which is Hund's rule. When filling the degenerate, what are the degenerate orbital? Important, you need to know what are the degenerate orbitals. Orbitals with same energy. When filling degenerate orbitals, always the lowest energy fills, and also it goes to the when it filling, always it fills to the next orbital other than, so first it's singly filled before spin pairing up, so it's filled to the next orbital other than pairing up the spin. So carbon, nitrogen 7, 1s2, 2s2, 2p3, like that. down like that. Okay, and then when you come to fluorine, it fills. No, after nitrogen, after oxygen, it fills to the next one. So these are the rules when filling the electron configuration. Thank you.